Hi, welcome to another video. So from that 250 watt KEF subwoofer amplifier, today I'm showing you a proper subwoofer, Mackie SWA1801. Now the SWA are regarded as one of the better subwoofers that Mackie made. I'll show you why in a minute. So that's the input, the power, signal, regular XLR, volume, phase reverse to match it with another sub or normal speakers, high pass out. So that's the outside of the amp. It's turned on at the moment, it's running nice and cool. That's important. If you got one of these and it's faulty, in the absence of a signal, does it run cold? Because it should. If it doesn't run cold in the absence of a signal, you've got a problem before you even start. So this is a powerful subwoofer, I think between 800 and 1000 watts, somewhere there. So I've got a resistor in a jar of water, which is actually quite warm, just to cool the resistor down, stop it burning out because this sub's so powerful. So there's my resistor, and I've got a sort of lead running into my scope, so I don't have to put my scope lead in the water. That's the signal we've got going in at the moment, 100 Hertz, 20 volts, peak to peak. So for the benefit of you who don't know what a Class B amplifier is, this is our alternating signal going in. 0 volts is in the middle. That's the positive half cycle. That's the negative half cycle. And in a Class B amplifier, you'll have transistors to give us this positive gain, and a second lot of transistors to give us this negative gain. If I expand this out, and a good Class B amplifier, you will see no crossover distortion where the transistors are crossing over, where one starts conducting and the other one stops, which is just there. So you've got input board up there, obviously ribbon cable down here. These LEDs are connected to the plus and minus 12 volts. These look like they're biasing for the input for the amplifier, so don't actually light up. Not sure about this one, not looked at it, not seen it. Op amp, so signal comes in here, but the output is fed back to this input, and then the gain on this changes with amplitude and frequency. So it's actually got a compression, and when it reaches maximum power at a specific frequency, the gain on this alters to compress the signal so you don't just blow the whole lot up. We've got a 60-degree temperature sensor there. This is one of the main drivers, one here, one down here, that drive two big output transistors here, two under there, two under there. From memory, unless I'm mistaken, this side does the negative half cycle, this side does the positive half cycle. These output transistors are emitter followers, so they deliver the supply directly into the speaker virtually. They dump the current, also the current amplifiers, they dump the current into the speaker, which is here, via these resistors. And incidentally, these resistors are rated at 0.22 ohms each. So what's interesting about this amplifier design, and if you watch my KEF amplifier repair, this had quite a few blown components, but for example, two diodes here, hopefully they're in view, this diode and this diode. That's a Zener, that's a normal signal diode, but rated, a lot of these components are rated at 250 volts or more. That diode had small holes, this bigger diode had bigger holes. So A, you can't get them wrong, but B, because that smaller diode had smaller holes, it's less susceptible to dry joints, because having a big hole, you'd have to cover it with lots of solder. So that's what I actually meant in the comment about the KEF. All the holes seem to be a bit too big for the components, Where this proper design amplifier, if it's a smaller component, it's got a smaller hole. Bigger component, bigger hole. So all the holes for all the components on this amp match the component going in. So if I show you these are all the smoothing capacitors for the amp. I'll discuss these in a minute. Clever design, I like it. That's a humongous toroidal transformer. I understand these aren't available. There have been some that have been built in China, and the Chinese have let Mackie down because the windings have been damaged. But if you've got one and the transformer's faulty, throw it away. These are actually rated at plus or minus 72 and plus or minus 15. Just get a plus or minus 60, so forget the extra 12 volts. Get a plus or minus 60, put it in there, plus or minus 15, stick it somewhere else, either in the cabinet or in here somewhere, and that's it. You've got your sub working again. If you need every single volt of that 72, plus or minus 72, to get your power, and you don't want to drop to 60, then your sub is wrong for the job. You should not need to drive these at full power. If you do, as I say, it's a wrong amplifier for the job. So plus or minus 72, plus or minus 15. So why is that plus or minus 72 and 15 relevant? Well, this whole Class B amplifier, when I was testing it, I was measuring the voltage on the collectors which are connected to the supply, as I said, because they're emitter followers, so collectors connected to the supply. I only had roughly 18 volts after the supply's been rectified and smoothed. 18 volts on the collector, 18 here, 18 here. So let's assume you get all that power out of the speaker. That's roughly 36 volts peak to peak. I thought, how can we have a sort of 1000 watt, 800,000 watt sub with plus and minus 18 volts? And that's where the clever design comes in. So as I say, you've got some drivers, a driver there, one under there, these two transistors, then the big power transistors, but then these extra ones in here, Q12 and Q9, I think it's that one. Clever design. When the signal reaches 1 volt across this transistor and this one, let me show you what happens. I'll show you on this side first. So this is the negative half cycle on the right hand side as we're looking at it. As the voltage rises on that transistor, this device starts working. So what on earth is this? So it's a FET driver isolated with an optocoupler, and most optocouplers, the LED inside wants roughly 1 volt. So when the sine wave reaches 1 volt, this starts turning on a FET driver that turns on a FET under there. So you think, well, what does that do? Well, these FETs are connected to that plus or minus 72 volt rail. So smooth comes up to roughly 160-ish. So when this opto isolator turns on, this drives this FET under here. This will pull the supply down to roughly minus 90 volts. And this opto isolator will pull the supply up to plus 90 volts. So 90 and 90, 180, roughly, maybe a bit under that. So what we effectively have here is, at low volume, we've got a Class B amplifier that will sit there and run all day, twiddling its thumbs at sort of 25-30 volts peak to peak. Powerful Class B doing that. Turn the volume up, these opto isolators start conducting, and the Class D starts cutting in, and these FETs start doing all the hard work. And as if you've seen my other videos, as with all Class D, these are the coils to take up the 400 kilohertz, or at least the switching frequency of these FETs. Now I guess to keep the package small, because they're so powerful with the amount of current we're going through the speakers, these coils are housed in, well, metal casings on top and a complete ferrite core, and the windings are enclosed. It keeps the coil smaller yet powerful. So they're not air cooled. Sorry, you're out of view there, so yeah. So the coils aren't open to the air, they're enclosed in the ferrite rings under here. So Class D and a Class B amplifier. So you might be looking at this FET driver sitting on 7 bits of wire. Unfortunately these opto isolators are now obsolete. So I'm waiting for someone in the UK, says he's got some down in Epsom. Didn't send them last week, said he ran out. So I don't know, do I wait for the proper one to come in, or do I just give this back to the customer with this, because this is actually working quite well. Not as well as this, and I'll show you on the scope. Right, so we're at 100 Hertz. If I turn this down like that, so at 20 volts peak to peak, I've got the amplitude 440 millivolts input. It's giving us our 20 at the moment. So this is just the Class B working by itself. Now the problem I've got with that FET driver, bearing in mind the original is now obsolete and unavailable, watch what happens when I turn this up. There we are. So just at 35 volts, you can see that white opto isolator FET driver is starting to cut in and drive this positive going signal. You can't see it with the negative one, the original chip. So if I carry on turning it up, turn it down a bit more. So that's at 65 volts peak to peak. Well, that's 130 you saw there. Actually, that just cut down by itself. What I don't want to do, which I did the other day, is blow this up. Because ordinarily, a sub would not have 100 Hertz going to continuously as I have with this sine wave generator. So that's sitting at 84 volts at the moment. If I turn it up a touch more, no, it seems to be that's knocking itself back to 85 volts. But obviously if this frequency was varying, it will shoot up and down. Actually I just saw it went up to 160 peak to peak. But I just don't want to destroy this amp, so I'm going to leave it 80 volts, 85 volts peak to peak. Now this is the problem here. This is that opto isolator switching on and off, putting a high frequency on this 100 Hertz sine wave. So if I stop this, capture this, I'll turn the amp down so we don't cook it. It's actually running lukewarm at the moment. So this noise, you can see the scope's measuring it. We're at 162 kilohertz, so you're not going to hear this. If I flatten it out, depending on where you choose to put the scope, that's like 10 or 2 and 10 volts peak to peak, that noise. But don't forget, so between 2 and 10 volts peak to peak, 160 kilohertz, but sitting on 85 volts peak to peak. So you're not going to hear, the frequency isn't in the audible range, and with this thumping going on, you're not going to hear this. So those coils take out the standard frequency from that standard opto isolator. Normally I would have a resistor and a capacitor on here to filter it, but on this amp I don't need to. That's the problem I've got, but as I say, you're not going to hear it. So yeah, my main question is, someone has said he's got an SMD version of these. He's actually on eBay and he's a reputable seller. He said he can get hold of some SMD versions, so I could stick one straight on there, just solder it onto the tracks. But let's assume they are obsolete, but let's assume you couldn't get anything. Then picking another opto isolator, different company, different design, you can actually get it to work. So the question is, do I send this out to the customer with this newer type FET driver with that noise on the sine wave that you can see, or do I wait and see what turns up from this other supplier? I've already been waiting over a week. He's let me down once already. Got to see if he can come up with these in another package. Now they list these in China on eBay, but I've had so many fakes it's unreal. So other than the fact these are obsolete, we have a really good subwoofer, a Class B meeting Class D down here, with an indestructible transformer, assuming it's been manufactured correctly. So we're at 12 volts peak to peak there, and you just see that FET driver starting to switch on, which is a bit of a shame you can see it, because other than seeing the noise, I'm sure you won't be able to hear it, but this would actually be perfect otherwise. So at 30 volts peak to peak there, and I can just see it starting to come in. So if you turn the volume down, the Class D cuts off, because those opto isolators need 1 volt to start conducting, 1.1. So Class B, and then Class D, pulling that positive high and the negative low. That's over 100 volts, so that's the power of a Mackie 450. I don't want to tempt fate, but hopefully you can see that voltage peaking at 130 volts. So that's a look at a clever design subwoofer from Mackie, the SWA1801. So between 8 and 1000 watt subwoofer. Proper design, proper PCB layout, quality PCB, quality components, and an ingenious way of mixing Class D with Class B. So hopefully it's given you some insight into your varying designs of amplifiers. Thank you very much.